This episode of DNews is brought to you by the U.S. Air Force.
Gravity affects us in ways we didn't expect. We know this by observing frogs. That's right, frogs. Hi all, I'm Ian O'Neill, space producer for Discovery News, and I wanted to chat a little bit about a frog named Xenopus laevis and a force called gravity. The Xenopus is also known as the African clawed frog, and biologists have been astonished by how big its cells are. On average, animal cells on Earth are around 10 microns wide, but the Xenopus cells are much, much larger. If a human cell was the size of a house, the Xenopus cell would be the size of the Empire State Building. Why is there such a wild size difference? In a new study published in Nature Cell Biology, researchers studied the architecture of cells found in the Xenopus eggs. These huge cells are markedly different from human cells in that they contain many membrane-less compartments inside the nucleus. These compartments are liquid-like drops filled with RNA and proteins known as nuclear bodies. In human cells, these nuclear bodies are supported by membranes that provide structure, preventing them from turning into mush. But with few membranes to support the nuclear bodies inside the Xenopus cells, why doesn't gravity take over, causing all the stuff inside the nucleus to sink to the bottom and basically turn into mush? There must be something countering this gravitational effect. After injecting a magnetized microscopic bead into one of the cells, the researchers were able to exert a magnetic field on that bead and observe how it moved within the cell. They found that the bead and the nuclear bodies were being held in place by a web of proteins known as an actin mesh. When the magnetic field was switched off, the bead returned to its original position as if it was embedded inside a cube of jello. As a space scientist, I've always been fascinated by how a space environment can affect biology. Simply by removing the force of gravity in experiments on the International Space Station, for example, this has led to many breakthroughs in medicine, cell growth, and developments in new therapies for disease. But as demonstrated by the small frog, nature has a few tricks up its sleeve to mimic a gravity-less environment inside the Xenopus cells, thereby boosting its size, making it more durable, and adept to supporting life. Wouldn't it be cool if we could develop this microscopic mesh for industrial purposes? Maybe it would make a good shock absorber. Who knows? What do you think we could learn from this fascinating research? Let me know in the comments below, and please subscribe for more DNews every day of the week.